Hello everyone, welcome to another episode of LeetCode Explore where we go over specific questions as part of LeetCode Explore cards. We're going to resume today in our exploration, no pun intended, of the LeetCode Beginners Guide, and the next question on our list is going to be number of steps to reduce a number to 0. I already have the question open here on this tab, so I'm just going to navigate to that tab so we can start with the question. So let's go ahead and read the prompt and let's think about how we can do it. So given an integer num, return the number of steps to reduce it to 0. In one step, if the current number is even, you have to divide it by 2. Otherwise, you have to subtract 1 from it. The way I like to approach this question is I feel like this is a question where they tell you exactly what to do, and all you have to do is do it. It's almost like you're simulating a given input, and you just have to come up with a way to modify the prompt and write code to reflect that prompt. So let's just go ahead and start off by doing exactly what it's telling us to do. Nothing more, nothing less. So we'll start off by declaring a variable. We'll name it steps. And now we can say while num. So while the number that we're given is truly, which means at least in this case, any number over 0. So 1 or more is going to give us a truly value and 0 will give us a falsy value. So while num, what is it that we want to do? Well, if num modulo 2 equals 0, which means that it is even, it says that we have to divide it by 2. So we'll say num equals math.floor of num divided by 2. We use math.floor here in JavaScript because JavaScript does not have truncation like we do in other languages. So we also have to make sure that we round it downwards to get the whole number. Else, we know that we're dealing with an odd number, and it says we have to subtract 1 from it. So we'll say num minus equals 1. And then at each one of these steps, we'll also increase the amount of steps by 1. And finally, we will return steps. So let's go ahead and open up our console. Let's get all of our edge cases here. Let's run this and let's see what we get. 6 of 4 and a 12, 6 of 4 and a 12. Let's submit this. All right, 29.04. This is one way of completing the question. And if we think about the time complexity, this is an interesting one because every time that we're doing num is either being subtracted or not yet. We're either subtracting 1 from num or we're dividing it by 2. The way that I like to see this is at every single step, we're sort of like halving the space, right? Halving the space. When I say halving, I mean like to take the half of something. So when I think about that, I think of something like a binary tree, right? If you make the decision to go left or right, at every single decision point, you are like splitting the question space, the problem space by 2, right? So because of this, and because it's sort of similar to that, I will say that this is actually the log of num is the time complexity here. And the space complexity in our case is going to be constant space. Now let's think about a different way of doing it. You can also sort of visualize this with a binary numbers. So let's take our number 14, for example, because this is the first example here. If we look at, I wonder if I should draw this. Well, let's do it this way. So let's say we have 0, 0, 0, 0, right? I'm going to give some space in between each of these numbers. Now, each one of these in binary, like this bit here stands for 8, this bit stands for 4, this bit stands for 2, and this bit stands for 1, which means that for us to get a 14, we have to turn on the 8-bit, turn on the 4-bit, turn on the 2-bit, and that gives us 14, right? Now, let's think about how we can go from, let's figure out how we need to do an even or an odd number, right? So we figure out that 14 is even. Now 14 is even because if we look at the least significant bit here, the bit that's at the ones place essentially, we see that this is currently 0, which means we don't have that extra 1 turned on to make it odd. So because of that, we can confidently say that this number is even. And to divide an even number by 2, all we need to do is right shift this number by 1. So we know that 14 divided by 2 is 7. And if we shift this number to the right by 1, we end up with a 0 here and a 1 here, right? And what does that give us? That gives us 7. And this to subtract 1, all we need to do is toggle that 1 bit right there, and then we get 6. So we can continue doing this onwards until we essentially get to the same thing while num is 0. So let's see if we can modify our answer to be able to do this. I'm going to uncomment this top piece right here, let steps equal 0. Matter of fact, I'm going to uncomment everything, and now I'm just going to change it to do exactly what we said here. So we need to be able to get the least significant bit here and see what it is, right? So we can say, let's see, if num and 1 right? Like if num and 1, right? You can imagine that if we have, let's say 110, which is 14, 1110, which is 14, if we AND that with the number 1, which you might imagine looks like this, what is that going to do? It's going to make everything 0, right? So if num and 1, if this ends up being truly, that means that this bit must be on. But since it's falsy, we know it's even. So what can we do? Here, we'll make our else, and we want to divide it by 2, and we know that means that we have to shift it over by 1. So here we'll say num right shifted by 1, and we'll use the right shift operator and the equal to compound them, sort of how we might do something like num plus or equals or num minus equals. And then finally, if it is, so let's say we just did the operation of the right shift, and now we're ending up at 7. Now num and 1 is going to give us 1. So really what we need to do now is we want to toggle this bit, right? And the bitwise operator that does that for us is an XOR to toggle a bit. So if we do num XOR equals 1, so the number XORed by 1 will just toggle this bit for us, and we'll end up with 6 because we'll end up with 0, 1, 1, 0. Hopefully that makes sense there. And we can sort of see how we got here, right? Like this is the 7 over here, right? And this is a 1. We XORed that and we ended up with 6. And then of course at the end, we'll still do our steps plus or equals 1. Let me go ahead and comment this out, and let's run that code again. So 6, 4, and 12. Let's submit this. 30.95. And if you want to be a little bit maybe clever, or you like using ternary expressions, I know a lot of people like to do that, we can say num and 1. We can go ahead and do this piece right here. Else we'll go ahead and do this. If you really want to keep everything on a single line, let's again run this through our test cases. 6, 4, and 12, 6, 4, and 12. And we end up with 48.46. So a similar way of doing it, I like the approach of being able to practice your bitwise operators here. I think it's a very important thing to learn. I wouldn't say that every question lends itself well to bitwise operators, but pulling something out like this during an interview, or mentioning it to your interviewer, describing your process with bitwise operations, definitely at least shows your interest in it and shows that you went maybe a little bit further in trying to understand it. So I hope that this video helped. We looked at the problem in 2 different ways, both of which have the same time and space complexity. So if you have any questions, comments, concerns, we'd love to hear about them in the comments below. And stay tuned for more videos in the LeetCode Beginners Guide Explore card. Until next time, happy coding.